Hello to you from Chem Help ASAP. Dose response is a very important idea. Let's see why. Here is a concentration response curve. The x-axis is log of concentration for some compound, and the y-axis is an effect. The effect could be anything, but it would likely be some measure of binding or other in vitro effect. This kind of curve is encountered early in a drug discovery program. Gathering data that generate this type of curve through an in vitro assay helps confirm that the compound is behaving in a normal and expected manner. This sigmoidal shape is a reassuring shape for an active compound. If a compound does not show a sigmoidal response curve, that could be a sign that the compound is not engaging with the target as expected. In other words, it would be a red flag that would merit additional investigation. This slide looks just like the previous one. Note that the x-axis has changed to dose. Log dose. So this curve is for an in vivo study in which a living organism has been dosed. The term in vivo refers to a study in a preclinical species. So these data would be from an animal disease model. The effect on the y-axis will correspond to some biomarker, likely hormone levels or body fat or blood pressure or bone density. The available data from various doses may not create the full sigmoidal curve. Regardless of whether the full curve is visualized, you are still looking for some kind of positive relationship between dose and response, hopefully with this sigmoidal shape. Finally, here is another curve. Again, it closely resembles the previous ones. This is again a dose-response curve. The relationship is sigmoidal. So we have a logarithmic x-axis for our dose, log dose. This curve is for clinical data, human data. Again, the available data will not likely generate the full curve. Specifically, a very high dose might lead to toxicity for the patient. So the data points may only allow construction of the lower portion of the curve. The y-axis is an effect or response. It could be a biomarker change. It could also be some kind of clinical outcome related to how a patient feels or functions or survives. An example would be a patient's memory or the distance a patient can walk in a period of time. These are not biomarkers, but they are valid ways to measure the health of a patient. These are clinical outcomes. Again, if the drug is working as expected, then you expect to observe a clear positive relationship between dose and response in patients. The observation of sigmoidal activity curves from in vitro data all the way to clinical data is a favorable indication that the drug activity is behaving normally. In summary, why are sigmoidal relationships important? They are the typical positive relationship between a well-behaved active compound and its effect. Please like, subscribe, and/or leave a comment. Take care.